Welcome back to math. Yay, I hope you had a good last quarter. We're starting week 10, which is a lot of review. We're going to talk about the zero product property, and we're going to get right into it. The big thing we want to know is what is special about the number 0. And so we're going to look at what happens when you add the number 0 and when you multiply the number 0. So the real simple thing is we're going to just calculate these sums. You might be looking at this and going, well, this is ridiculous. We know this is 3, 6, -7, -2. And what's special when we add 0 is you get what? How are we going to call it? The same number back, right? You get the same number. It doesn't change, okay? There's no change when you add 0. And if you were thinking about this abstractly, like Julie is thinking of two numbers A and B, and when she adds them, she gets a sum of B. Well, what does that tell you about the other number? So she gets A plus B equals B. Well, what do we know about that? We know that A must be 0. And the reason we know that is because then that would be 0 plus B equals B, right? So when you add 0 to something, it's special because it doesn't change that original number. You get that same number. And what happens when you take the product? This one's even easier, and this is more important because this is going into our zero product property, what we're talking about. We know we're going to get 0. We always get 0 when you multiply by 0. Okay? And here she is. Julie is thinking abstractly again about two numbers, A and B, and when she multiplies them, A times B, she gets 0. So what does that tell you about these numbers? Well, what that tells us is that I could have 0 times B equals 0, or I can have A times 0, make this a little better looking, A times 0 equals 0. So that means either A or B is 0. And the rest, I'll show you why that idea, how that goes into what we're going to be talking about today. Because A times B is 0, that means either one of those has to be 0. So let's look at this problem right here, applying the zero product property to this quadratic equation. We're going to have 2x squared plus 5x minus 12. So let's review setting that up, and we want to take 2x squared plus 5x minus 12. See how that equals 0? We want to factor that. The easiest way we've been organizing our thoughts in factoring is to use this box. So if I remember, 2x squared negative 12, and then if we multiply those, we get negative 24x squared, and then we take this number and put it on the bottom, 5x. So what numbers can we think of that multiply to 24 that we can get a 5 out of? How about negative or positive 8x and negative 3x? A positive times a negative is a negative, and then 8 minus 3 is a positive 5. So here we're going to get an 8x and a negative 3x. So now we have to think, what numbers are we going to pull out of those? Let's start factoring that. So when I look here, I can see I can take out a 2x. 2x times x is x squared. Well, 2x times what equals 8x? How about a 4? And then I go like this. X times what equals negative 3x? How about negative 3? And that works out nicely because 4 times negative 3 is negative 12. So we know these are our factors. So we've now factored this to x plus 4, 2x minus 3, and that equals 0. Now here we are to our zero product rule. Remember Julia back here in this problem? She was thinking of two numbers and they multiplied to equal 0. So here's two terms right here, x plus 4 and 2x minus 3, and we multiply them to equal 0. And so that means one of them has to be 0. That means either x plus 4 equals 0 or 2x minus 3 equals 0. So we have to solve each of those problems. So when I do this, I subtract 4 from both sides. I get either x equals negative 4. That's one of my possible answers. And this one, I'm going to add 3 to both sides. I'm going to get 2x equals 3. Divide by 2. And we get x equals 3 halves. That's my other option for x. So now that the equation is written as a product of factors, you can use the zero factor to solve it. Use one factor at a time. I already did this information. Use one factor of time and see what makes it equal. So we found out that x equals -4 or x equals 3/2. And why is that important? The reason, you probably want to see what I'm writing. So I did this right here, use one factor at a time to set it equal to 0. I did that up in this space here. Why is that important? Because what we're discovering is that if x equals -4, I can go graph that. X equals -4 or x equals 3/2, which is 1.5. So 1.5. So we know that these are my x-intercepts. And because this first number here is positive, that means it opens up. My parabola is going to be something like this. And we know that the vertex is going to be somewhere between, or actually we're reviewing that. So what other piece of information do I need to sketch the graph? It says y-intercept. We need the y-intercept. So let's see where the y-intercept is. The y-intercept is when x equals 0. So we're going to take our equation, 2x squared plus 5x minus 12 equals 0, but this time we're going to just set it equal to y. We're going to plug in 0. 0 squared times 2 plus 5 times 0 minus 12 equals y. 0, 0, negative 12 equals y. So that's going to tell us that this is -10 at -12, which we'll just say right here. That's going to be our y-intercept. So we know this graph is going to look something like this. Oops, I didn't draw it very perfectly, but you get that it's going to go through the y-axis at -12. It's going to hit these, and then somewhere over here is our vertex, and we're going to get into that later. Let's look at the next page, page 2. So right now we're just going to focus on finding what our zeros are. And finding our zeros means that we're going to find where is the x-intercepts of the graph. So here we go. We're going to say x minus 2 equals 0, x plus 8 equals 0. To apply the zero product property, we're going to set each term equal to 0. So here I'm going to get x equals 2 and x equals -8. Those are my answers for part A. Part B, we get 3x minus 9 equals 0 and x minus 1 equals 0. I'm probably going kind of fast for this video, so you can always pause at any time because it is a review. So we're going to subtract or add 9 to both sides, and I get 3x equals 9. Divide by 3, get x equals 3 here. And this one I'm going to add 1. You get x equals 1. Pretty simple. Next problem, x plus 10 equals 0, 2x minus 5 equals 0. So again, we want to figure out what value is going to make that equation equal to 0. And by doing that and solving these problems, we are finding where the parabola or the graph will hit the x-axis. So we're going to solve this one. 5/2 is our answer, or that's 2.5. Okay, that helps because 2 goes into 5 2 times with 1 remaining, so 2.5 or 2.5. Sometimes you'll have a problem like this, x minus 7 quantity squared, and that just means that that's going to hit the x-axis one time, so I only have to solve it once. Here, this I get x equals 7. So these 3 problems that we did first, they're going to hit the x-axis 2 times at the points that we found, but this problem's only going to touch the x-axis 1 time, so it's probably going to look something like this. 1, 2, 3, 4, 5, 6, 7. This is 7. It's going to look something like that. You probably want to see it. It's going to hit the x-axis just 1 time, whereas these are going to touch at 3 and 1. It's going to touch something like that. Okay, we'll talk about finding the vertex as we move further in there. Let's just still practice finding 0, the zero product property. In this problem here now we have to factor this. X squared and 21. So we're going to get 21x squared. You multiply those two together to get the top term. The bottom term goes down here. And we play the game. What numbers multiply to make 21x squared? That add to make 10x. 7x and 3x. And I can put 7x and 3x in here. We're going to go ahead and solve that. And we're going to get x times x makes x squared. So that makes 3. 3 times x is 3x. And then here you can see a 7. So here are my terms right here. X plus 3, x plus 7. And all we're asked to do is factor them. So we just want to put them as their terms. Let's go ahead and do this one. This is a way to organize our thoughts. X squared and 42. Multiply them across. That goes on the top. 42x squared. Or that should be an x. I don't know why it's a p. We probably copied it from another problem and never changed it over. 13x. So let's see, what multiplies to 42 that I can get a 13 out of? Now a way to think about that are, what are numbers that multiply to 42? 2 times 21. 3 times 14. Well, 2 and 21 I can't add to make a 13. 3 and 14 I can't add to make a 14. What about 6 and 7? 6 times 7 makes 42, and it adds to make 13. So what if I made them both negative, and negative makes a positive? So we go negative 6x and negative 7x. Now again, we are going to have x times x. That gives us the x squared here. What multiplies to make negative 6x? Just the negative 6. And this is negative 7. Negative 6 and negative 7 makes 42. So our terms for this one are x minus 6, x minus 7. Or x minus 7, x minus 6. Doesn't matter how I write it. Okay. We're going to keep going here. A couple more problems. Let's just organize our thoughts. I'm going to put 5x squared here and a 4 here. I'm going to multiply those, and I get 20x squared. This is a negative 9. So what multiplies to make 20 that I can add to make negative 9x? How about negative 5x and negative 4x? Because a negative and a negative make a positive. Negative 5 plus negative 4. So I'm going to put negative 5x, negative 4x. And again, I'll go through my process. If I make this an x, then this has to be a 5x, because x times 5x is 5x squared. But now this needs to be a negative. Let's make it a negative 1. So now this has to be negative 1 times what makes a positive 4, and negative 4. So here's my terms here. X minus 1, 5x minus 4. Okay. And in the last problem, again, look at how every single time we set up our thinking by using this box. It helps us organize. So we're going to get minus 5. We're going to multiply across. I'm going to get negative 35x squared. Put this middle term at the bottom. What multiplies to 35 that I can get a 34 out of? How about 35x and 1x? Make this one negative. 35 minus 1 is, no, make that a positive, because I need that to be a negative 34. So now we go negative 35x and positive 1x. Okay, let's go through our process. Here I go, x and 7x. Well, 7 times what makes negative 35? The negative 5. Negative 5 times what makes 1, or negative 5 times 1. So now here are my terms. X minus 5 and 7x plus 1. Okay, we have just factored that. That's a big, huge deal. Let's look at the last problem. Again, we're going to find the x-intercepts, set up our thinking, x squared and 6, multiply them. 6x squared, this goes on the bottom. I'm going fast. How about negative 6 and negative 1? A negative makes a positive. Negative 6, negative 1. So now we're going to go, let's see, x times x, make this a negative 6. There's supposed to be x's here. And this becomes a positive 1. So you have x minus 6, x plus 1 equals 0. Solve each of those for x. You get x equals 6 and x equals negative 1. Why is that important? Because these are our y-intercepts. So I'm going to go to graph them. Oh, I put that at 2. It should be at 1. to find the y-intercept, we'll do that later.